Welcome to this class, and today we'll be doing some questions based on measurement and units. So the first question here says, which of the following is not a base quantity in the SI system? Which of the following is not a base quantity in the SI system? Option A says time, option B says luminous intensity, option C says temperature, and option D says velocity. Now, both your luminous intensity, and your temperature are base quantities. So the correct answer to this question is velocity, which is what? Option D. Moving on to question number 2. It says, a Vernier caliper has a least count of, so our least count here was given as 0.02 millimeters. A measurement read, so our measurement is reading 2.36 centimeters, which is the same thing as saying I have 23.6 millimeters. See, how many divisions on the Vernier scale coincide with the main scale? So it means my Vernier scale here is 0.6 millimeters. Looking at this, so the main scale here is 23, and this part, the decimal part, is my Vernier scale. So it means my number of division is equal to my Vernier scale over my least count. And that would mean that I have what? 0.6 divided by 0.02. So I have 0.6 divided by 0.02. And that would mean that I have what? 30 divisions. So 30 divisions coincide with the main scale. So moving on to the next question, which is question number 3. It says, which SI unit is equivalent to kilogram, meter squared, per seconds cube, per current? That's per ampere. So looking at this, they are trying to talk about what? Different quantities, and all of this, if you look at all of the options there, you have to find what? The one that has to do with this. So looking at this, first thing, let's start with the first one. The first one here is what? Volt. And we know our volt is the unit of voltage or potential difference. I will say that what? Our potential difference is what? The work done in moving a charge, which means what? Work done over charge. And that means that my voltage is equal to my mass times acceleration times distance divided by charge. And we know that my charge is equals to, Q is equals to IT. So this is the same thing that my voltage is equals to mass times acceleration times distance over current times time. So this means that my voltage will be equals to, mass is measured in kilogram, times my acceleration is measured in meter per second square, times my distance is measured in meters, divided by my current is measured in ampere, times my time here is measured in seconds. So this will mean that I have kilogram, meter square, meters times meters, over seconds square, divided by ampere seconds, which is the same thing as saying that I have so this simply means that I have kilogram, meter square per second square times 1 over ampere seconds. So this will give me kilogram, meter square per seconds cube per ampere, which is the same thing as saying kilogram, meter square per seconds cube per ampere. So looking at what we have, is it the same thing as the question that we are given? So we have kilogram, meter square per seconds cube per ampere. It means that this unit here is equivalent to the volt. So the correct answer to this question is option A, which is the word volt. Moving on to question number 4. Question number 4. It says the reading of a micrometer screw gauge is, so we have the reading of a micrometer screw gauge to be 5.78 millimeters. Said, but the true length is 5.75 millimeters. So if you subtract here, you discover that what? Our error is 0.03 millimeters. Then it said, what type of error is most likely present? Now, this kind of error is what we call a systematic error, because the error is slightly different from what we have in the original length or in the actual length. So this is what? A systematic error. Moving on to question number 5. It says, which measuring instrument would you use to measure the thickness of a human hair accurately? Now, in a video I did on this topic, I explained very vividly that if I want to measure the thickness of the human hair accurately with very minimum error, what I'll be using is the micrometer screw gauge. So the correct answer to this question is option B, micrometer screw gauge. So if you have not watched that video on that topic that I did earlier, please go back and watch it. Moving on to the next question, which is question number 6. It said a digital balance shows fluctuations reading for the same object. This is an example of, now when a digital balance, which is used for measuring mass, shows fluctuation in its reading, that means it does not show the exact same reading for the same object. It's consistently changing. This is a kind of error that we call random error. So the error is not consistent. It is not the same. It's constantly changing. So if it measures 20.5, the next minute to measure 20.4, the next minute to measure 20.0. So that is what? A random error. And that the example of this error is what? Random error, which is what? Option B. Moving on to question number 7. It says, which of these pairs has both quantities as derived quantities? Which of these pairs have both quantities as derived quantities? Option A, force and time. Force is derived, time is fundamental. Option B says pressure and velocity. Option C says temperature and energy. Option D says mass and acceleration. Mass is fundamental, acceleration is derived. Temperature is fundamental, energy is derived. Pressure is derived, velocity is derived. So the correct answer to this question is option B. So that is also question number 8. Which says, which SI-based unit is defined by the constant speed of light in vacuum? Now we know that speed of light, or speed generally, is equals to distance over time. Distance, so our speed, which is also velocity, is distance over time. So if my speed is distance over time, it means that my velocity is simply the rate of change of distance. So I'm talking about what? Distance. And because I'm talking about distance, and I said in the video that I did on this topic that what? Distance is a function of length. And because it is a function of length, it means it's talking about what? The meter. So because it is a function of length, it means it's talking about what? The unit meter. So it means that my speed of light in vacuum is a function of what? Meter. So the correct answer to this question is option B, which is the word meter. So that is the question number 9. Which says, what is the main cause of zero error in a micrometer screw gauge? What is the main cause of zero error in a micrometer screw gauge? Now, zero error is a type of error that is observed when an apparatus does not start from zero. So if the apparatus does not start from zero, we call it what? Zero error. And this kind of error can only be gotten when the micrometer screw gauge is now 40, when it is 1 half. So the correct answer to this question is when it has a 1 half spindle. When the spindle is 1 half, so it will not work completely rotate anymore. So if it does not rotate completely, then it is what? 1 half. And that is when the spindle is completely 1 half. So the correct answer there is what? Option A. That is also question number 10, which says, if an instrument reading are very consistent but far from the true value, the measurement is dash. Option A says accurate but not precise. Option B says precise but not accurate. Option C says both accurate and precise. Option D says neither accurate nor precise. Now we said that if the values are very, very consistent, that means they repeat themselves over a period of time, then that particular measurement is precise. But if they are far from the actual value, then they are not accurate. So the correct answer to this question is precise but not accurate, which is what? Option B. So that is also question number 11. Question number 11. We say, define the term least count and explain its significance in measurement. Least count just talks about the least amount or the smallest value that a measuring instrument can detect. The smallest value that a measuring instrument can detect, or the smallest amount that a measuring instrument can measure. So the least count differ from one apparatus to the other, and it is also the degree of accuracy of that measuring instrument. So what do I mean? It means that if I have a meter rule and I have a micrometer screw gauge, their measuring accuracy are not the same. So if I want to measure a very tiny object, I cannot take what the meter rule to measure the thickness of a piece of paper, while it will not be accurate, as the meter rule measures in centimeters and its measuring accuracy or its least count is about 0.1 centimeters. And if I have 0.1 centimeters there, it means it is not as accurate as the micrometer screw gauge that can measure up to 0.1 millimeters. So their measuring accuracy are not the same. So that is that on least count. So that is also question number 12, which says, distinguish between systematic errors and random errors. Now, I said earlier in a video where I talked about this topic that in systematic errors, that these errors are predictable and they are repeated. So you can easily repeat it. They are what? Repeatable. So they continue to repeat themselves. An example is a fault in your measuring instrument, like let's say a meter rule that does not start from 0. So it has a 0 error. So each time that it's starting, let's say it starts from 0.5. So it means that each time I'm doing my measurement, if I use that meter to measure a length, and that length was originally 20 centimeters, it will be measuring 20.5 centimeters. So this is what we call what? A systematic error, because it will continue to what? Repeat itself. And it is what? Predictable. But for random errors, they are not predictable and they are not repeated. So it happens haphazardly. It's random. So you can have a measurement of 20.5 centimeters, and then somebody else will do that same measurement with the same instrument, and then you have, let's say, 20.6 centimeters with the same instrument and the same object. Somebody else will measure that same object, and you have 20.80 centimeters. This is what we call what? Random error. So you can have it in any apparatus as well. So moving on from there, question number 13 says, why is calibration of measuring instrument important in experimental work? So if your measuring instrument is not calibrated, then first you are going to be having what we call systematic error. So if your measuring instrument is not calibrated, you have what? Systematic error. So calibration is just the system of numbering or giving values to your what? To each part or each step of your measuring instrument. And it is very, very important in experimental work, so as to what? Reduce error and ensure accuracy. So that is also question number 14, which says, explain why the SI system is preferred over other systems of measurement. Now, the SI system of measurement ensure that first, that there is universality. What do I mean? it is universally acceptable. And another thing, it is what? Coherent, meaning that what? You can use it to get other quantities. You can derive other units from it. So that is what? It is what? Coherent. Then it also ensure that it can accept prefixes. So you can put prefix, like if you want to calculate length and that length is very, very small, I can have prefix such as millimeters. So I've added milli to it. That is what? Milli, there is what? Is a prefix. So these are some of the reasons why this the SI system is preferred to other systems of measurement. Moving on to question number 15. Question number 15 says, what is meant by dimensional homogeneity in physical equations? Give an example. Dimensional homogeneity is simply saying that what? All the terms must have the same dimension. So all the terms of an equation, when all the terms of an equation have the same dimension, then we say what? It is dimensionally homogeneous. So example of this, you can have a quantity such as, let's say I have S is equals to UT plus half AT squared. So looking at this, my S here is talking about what? Meters. So I have what? Meters is equal to, here I have what? Velocity times time. My velocity is what? Meter per seconds times seconds. Plus, this here I have acceleration is meter per second square times second square. So looking at this, you know that what? Here I have all of my what? Everything here, they are what? The same. How? Seconds will cancel out seconds, second square will cancel out second square. It means what I have here is meter is equals to meter plus meter. It means here that this quantity here, this term here is the same as this term and is the same as this term. It means that what? This particular equation is dimensionally homogeneous because all the terms are equal. Moving on to question number 16. It says, how would you minimize parallax error in reading a laboratory thermometer? Now, parallax error is an error due to human mistake or eyepiece mistake, meaning that you are committing it as a result of what? Not reading the apparatus accurately. How do you minimize it? The first thing that you do is to ensure that the meniscus of your thermometer is in the same eye height, like you put it right in the same length or the same height with your eyesight. Another thing that you do is to ensure that the calibration is mirrored. What do I mean? That calibration is bright and can be easily seen. So you ensure that the calibration is mirrored or bright and can be easily seen. That way you can minimize parallax error. So moving on to the next question, which is question number 17. It said, convert 72 kilometer per hour to meter per second. So we know that 1 kilometer is equals to 1,000 meters. And we know that 1 hour is equal to 3,600 seconds. So it means that my 72 kilometer per hour will be equal to 72 times. So my 1 hour is 1,000. 1 kilometer is 1,000 divided by my 1 hour is 3,600 seconds. So these 2 zeros will cancel out 2 zeros. It means I have 72 times 10 divided by 36. So I have 720 divided by 36. And that will give me 20 meter per second. So it means that my 72 kilometer per hour is equivalent to 20 meter per second. So that takes us to question number 18. It said, derive the SI unit of pressure from base units. Derive the SI unit of pressure from base units. So we know that the pressure of a liquid is force over area. So we know that what pressure is equals to force over area. So this is the same thing as saying that my pressure is equals to, my force is mass times acceleration over area, which is what? Length times breadth, or length times length, as in this case. So this means that I have my mass here is what? Kilogram. Acceleration is meter per second square, divided by length times length is what? Meter times meters. So this will mean that I have kilogram meters over second square divided by meters square. So this is the same thing as saying I have kilogram meter per second square times 1 over meters square. So this square here will remove the meters here. So I'll have kilogram per meter second square, which is the same as saying I have kilogram per meter per second square. So the unit of pressure will be kilogram per meter per second square. So that is also question number 19. Question number 19 says, an object's length is measured 5 times as, so we have the measurements as, so we have the measurement as 20.1 centimeters, we have 20.3 centimeters, we have 20.2 centimeters, we have 20.1 centimeters, and we have 20.4 centimeters. Then the question said, calculate the mean length and comment on its precision. So the mean length is simply 20.1 plus 20.3 plus 20.2 plus 20.1 plus 20.4 divided by 5. So that will give me 20.1, 20.2, 20.3, 20.4, 20.1. So if I divide by 5, I'm going to get 20.16 centimeters. 20.16 centimeters. So this is the mean. So my mean is 20.16 centimeters. Now that I've gotten the mean, the range, what is the range? So our range here is 20.4 minus 20.1. It means what I'll be having is 0.3 centimeters. So looking at this means that what these values are what? Slightly precise or fairly precise. We can say it is fairly precise. And why is it fairly precise? Because the range here is fair for a meter rule reading, looking at 0.3 centimeter difference. So it is fairly precise. So that is also question number 20. We said, why is a stop clock more accurate than a wristwatch for laboratory time measurement? Now, if you watched our video on measurements and units, you will see I explained there that in certain conditions that a particular apparatus is preferred to another. So, for example, in a laboratory experiment, we cannot use a wristwatch. Why? Because a wristwatch measures its time in seconds. The least time that you can measure, or our least count there, is what? 1 second. So the least count there is what? 1 second for a wristwatch. So if you look at your wristwatch, it does not measure time in 0.1 seconds. No, it measures what? In 1 second. So because it measures in 1 second, we cannot use what? A wristwatch. Instead we use what? A stop clock or a stopwatch. So whether it's a stop clock or a stopwatch. So a stopwatch can measure up to 0.01 seconds. So the degree of accuracy has what? Increased. So the lower it can measure, the more accurate that device is. So the reason is simply because of what? Its degree of accuracy. So we've come to the end of today's class. Thank you for sticking with us. Don't forget to go to our channel to check other videos on other topics and other subjects that we have done.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 type of different exams, including JAMB, WAEC, Cacao,